Hi, everyone. This is Miss Hawkins. So this lesson tonight, or today rather, is looking at lesson 7, shopping for cats and dogs. Again, remember Carlos and Carlita are dear friends. And now they have to figure out cat and dog food or other supplies. Okay. So we've been looking at systems of equations, figuring in how to solve them either with graphing and finding the point where these two lines intersect. We've also used substitution. We solve for one variable and then we solve for, let's say we solve for x and then we have to substitute that back in and solve for y. Today we are going to look at the elimination method to solve linear equations. So let's look at this very first problem here. All right, it says one week Carlos bought 3 bags of Tabitha tidbits. So let me get my pen here working. Yeah, there we go. 3 bags of Tabitha tidbits and 4 bags of Figaro flakes. So I'm just going to highlight or underline the key information I need. I know that 3 bags of Tabitha tidbits is going to be important. 4 bags of Figaro flakes is important. And that the total cost was $43. All right, and now I'm going to change my color here. Let's change it to blue. Why not? Is it going to work? Yeah, there it goes. The next week, he bought 3 bags of Tabitha tidbits and 6 bags of Figaro flakes, and now this total now was $54. So based on this information, I already know that I have 2 linear equations that I can write here. So I'm going to write 2 let statements, or one for each variable I see. So let x equal Tabitha tidbits. Now I'm just going to abbreviate that as Tabitha. And let y equal the flakes, right? The Figaro flakes. So that would be true in the first equation I noticed as well as the second equation. So let me change my color here to black. So I see the first equation is 3 bags of Tabitha tidbits. So that would be 3x plus 4y equals 43, right? The second equation, 3 bags of Tabitha tidbits, so it's again 3x, plus in this situation, 6y equals 54, right? So let's just, we wrote our let statements. We have our 2 linear equations written in standard form. And now I'm noticing my coefficients next to my variable. I want to find where I have the same, or if I don't have it, I will make it the same, where my coefficient in front of my x or my y variable is the same. So I notice here I have 3x with the first equation and 3x with the second equation. They are the same. This is very important. So now I want to eliminate them by subtraction. So why do I want to eliminate them? It's because now if I do 3x minus 3x, well, that's 0, right? And here I can subtract the rest of this. 4y minus 6y, I have a negative 2y. And 43 minus 54, let me grab my calculator. All right, pause it to grab my calculator. So I got a negative 11, right? So again, if I have 0, I don't really even need that 0. So let me get rid of it. So you notice now I have eliminated one variable. I can just simply have negative 2y equals 11. I can solve for y. So I'm going to divide both sides by negative 2y, or negative 2 rather. Y is going to equal 5.5. So to go back to the problem, it says here, Figaro flakes, right, equals y. So 1 bag would cost $5.50. But I want to now solve for x, right? I take this value and substitute it back into one of these 2 equations. So I'll pick this one, 3x plus 4. But instead of y, now I'm going to write 5.5. Right? Because I substituted that value, and that's going to equal 43. So now I have 3x plus, what does that equal? 20, 20. So 5.5 times 4 is 22. Equals 43. Again, now I'm just again viewing this as a linear equation, solving for one variable instead of two. So I can see that cancels out. I have 20. And then this, oh, 20. I was about to say, I was like, this should be 21. Yeah, 22. So subtract that, subtract this, right? So I get 21, 3x. Now I'm going to divide both sides by 3. X equals 7. So Tabitha Tidbits is $7 a bag, and flakes are $5.50. So we're going to do one more problem, similar to this, but a little different. Here again, Carlos is buying more. Looks like he's buying dog food now. So let's say we have again 2 bags of Brutus Bites and 3 bags of Mighty Mix. And the total would be $42.50. The following week, he bought 5 bags of Brutus Bites and 6 bags of Mighty Mix. And now it costs $94.25. Okay, so let's write our let statement. So let X equal Brutus Bites, and I'll just write it B, and let Y equal M or Mighty Mix. So we have our 2 variables, we defined it. So now let's write our 2 equations. We have 2 times, well, Brutus Bites is X, so 2 times X plus 3 bags of Mighty Mix, so 3 times Y, for a total of $42.50. And then we have our second one, which is 5x plus 6y equals $94.25. All right, so unlike the last equation, I'm just going to go back to that one where we had the first coefficient, the coefficient in front of the x were the same, right? Really easy peasy. I could just notice right away I have to subtract it. Now I have to figure out how I can find a coefficient that will be the same because I have to make it the same either with multiplication or division. So I'm looking at my 2 and my 5. They're not the same. Could I multiply easily 2 times something to get 5? No. Could I multiply or divide something by 5 to get 2? No. Nope, not going to work. I'm not going to do my x's. Let me look at my y's. Can I multiply something by 2 to get 3? Yeah, I can multiply it by 2. I'm sorry, did I say that right? Can I multiply something by 3 to get 6? Yes, I can multiply it by 2. Or I could divide 6 by 2 and get 3. Okay, I just want to make sure I said that right. But I notice right now, if I had to divide it, I would have to divide everything here. So I want to start by multiplying everything in this first row, right? Multiply it by 2. Again, because I want to figure out how I can eliminate one of my variables. And I'm aiming now for this y here. So if I multiply that by 2 times 3, that's going to get 6. I can subtract it, but I have to do everything. Okay, so I'm just going to rewrite it down below. Let's see if I can change the color here. Yep. So this is now my second equation. I'm going to write the first equation underneath it and subtract. So 2 times 2x is 4x. Again, just think about distributive property. 2 times 3y is 6y, which is what we were aiming for. And 2 times 42.5, I believe it was 85, right? So now we have our 2 equations. Now, this one is equivalent to this one, right? So now I want to subtract. And I'll go back to black. So I'm going to subtract these. So 5x minus 4x is 1x, but I don't need that 1, so I'm just going to put x. And 6y minus 6y is 0, which is what we were aiming for. So they're gone. So I have x equals 94.25 minus 84. So let me get my calculations. 94.25 minus 85 is $9.25. So that's the cost of X, which is Brutus Bites, which is not cheap. All right, so I changed that, and now I'm going to, actually, dog food is probably, that's about right. All right, so now I'm going to put that back into one of these equations. I can choose. I can do this one, I could do this one, or I could do this one. I think I'm going to choose this one, okay? Because again, these two equations are equivalent, right? So I have 4 times, well, my X now is being replaced by $9.25 plus 6y equals 85. So I'm going to figure that out really quickly because we're running out of time. 4 times $9.25 gives me $37. Or yeah, $37 plus 6y equals 85. I'm going to subtract both sides by 35. Again, I'm solving for y now. Boom, that's gone. 85 minus 37 equals 48. And now I have 6y divided by, or 6y equals 48. So I'm going to divide both sides by 6. Y is going to equal 8. Okay? So let me write my ordered pair. $9.25 for my BBs and 8 for my MMs. All right, cool beans. All right, so hopefully this is helpful. I will talk to you later. Bye.